Okay, before we go over these, I want to go over our options. When we are changing a fraction to a decimal, what is option 1? We have 3 options. I want option 1, the easiest. What's our easiest option, Fisher? No, that's not the easiest. What's the easiest? Option 1, easiest type of problem they could give me. Addie?
9/10.
Addie?
9/10.
Okay, why would that be an easy one? Why would 9/10 be an easy one?
Because it has a 10 in the problem.
Yeah, so the easiest problems. Option 1 is the denominator is already a 10, a 100, or 1,000. Those should be our easy ones that we like to see. What's option 2? Kind of the medium ones. Elise?
Making it into simplest form.
Not simplest form, but where we can easily change it to what? Not to a decimal. Carter? Where we can easily get the denominator to 10, 100, or 1,000. Now, I will tell you, every single problem on your homework last night, you could do that. You did not have to do option 3, the hard one, a single time if you could figure it out. There were a couple of them where it took you 2 steps to get it to 10, 100, or 1,000, but it was possible. Now, on those 2 that were kind of tricky to get there, what is option 3? Option 3 works every single time if you wanted it to. Okay? You can, it's not suggested if it already has a denominator of 10, 100, or 1,000, but option 3 works every single time. If 1 and 2, if you're like, nope, I can't figure that out that way, I can't figure it out that way, option 3 works every single time. What was option 3? Addie J? Divide it out, okay? And we just have to keep in mind, it's numerator divided by denominator, okay? Top divided by bottom, just like it looks in the problem, okay? So when we go through these today, when we do them on our paper, on our loose leaf, the extra examples, we're going to work one problem all 3 ways, just to show you they all work. It's just not always you pick which one works best for the problem you're working on. Okay, you have options. Let me get to the correct page. Okay, and when you turn in your worksheet tomorrow, you must have work shown. I don't want just answers, I want your work to back it up. Now, which ones don't really have any work? There are a few that won't have any work. What kind doesn't have work? Elia?
The ones with 10, 100.
Yeah, the ones that have 10, 100, or 1,000 underneath. So when we go over these today, I'm going to model and show you, which just like we did yesterday, the work that you should have. Okay, number 1. Clara, is the denominator 10, 100, or 1,000? No. Option 2 is to do what? Yeah, get the denominator to 10, 100, or 1,000. Can I easily get 2 to 10, 100, or 1,000? By doing what? Multiply it by what? By 5. So I have to multiply the top. I'm creating an equivalent fraction of 5 over 10. How do I say that properly, Jackson? 5/10. How do I write 5/10 as a decimal?
0.5.
0.5. Next one, 11/20. Aubrey, is this an easy one? Is this an option 1 type? Does it have a denominator of 10, 100, or 1,000? No, so it's not one of the super easy ones. Can I get 20 to 10, 100, or 1,000? Yes? What's our brain? We want to keep it as small as possible, but why can't I get this one to 10? Why shouldn't I get it to 10, Hutley?
Because 11 can't be a whole number divided.
Yeah, because if I take 11 divided by 2, I get a decimal number, not a whole number. So this one, what do I do? Since I don't want to break it down to 10, Addie J, what should I do?
Multiply by 5 to get it to 100.
I can go to 100 fairly easy. So 11 over 20 times 5 times 5. That'd be 55 over 100. What is that as a decimal, Carter? 0.55. 0.55. Good job. Next one, 13 over 20. Aiden, option 1, option 2, or option 3?
Option 2.
Okay, why is this a 2? Option 2.
Because it doesn't have a 10, 100, or 1,000.
Yeah, it doesn't have a 10, a 100, or 1,000. And again, I always want you to try and make it the smallest denominator possible. So the smallest possible will be 10, because I can take 20 divided by 2 and get 10. Can I take 13 divided by 2 and get a whole number? Nope, so 10's out. So Gabe, where do I have to go?
Times 5.
Times 5 to get me to 100. Gabe, what did you get when you took 13 times 5? 65. And how do I write that as a decimal? 0.65. Next one. Lexi, option 1, option 2, or option 3? Number 4.
Option 1.
Option 1, those are the easy ones. Why?
Because it's a 10, it's a 10 and it needs to be a 10, 100, or 1,000.
Yeah, because it's already a 10, so how do I write that as a decimal?
0.6.
0.6. So these are the only kind on tonight's worksheet that shouldn't have any work, are our option 1s. Next one, Kinley, option 1, option 2, or option 3?
Option 2.
Option 2, why?
Because you can do 25 times 4 to get to 100.
Yep, because I can multiply that 25 by 4 to get it to 100. What is 13 times 4?
52.
52, and how do I write that as a decimal?
0.52.
0.52. Number 6, Wyatt, option 1, option 2, or option 3?
Option 2.
Okay, why is it an option 2?
Because it's not a 10, 100.
Okay, it's not a 10, a 100, or 1,000. What did you do here?
I multiplied it by 5.
Okay,
We got 100.
okay, and what did you get on top?
70.
70. So he got 70 over 100. Now, I'm going to pause here. If you gave your answer as 0.70, you're not wrong, but who knows why that's maybe not the best answer. Okay, last night I would have gave it to you because it's day 1 and we didn't have any like this. Why is that maybe not the best answer, Elise?
Because you don't need the last 0.
Yeah, because when we're writing decimals, do we need the extra zeros at the back? No, so if you wrote 0.70, next to it I just want you to write equals 0.7. Now here's something else I want to show you that we've done it before, but looking at this fraction, here's one way where you could have simplified it here. If we have a 0 on top and bottom, what happens to it? Of a fraction, it cancels. Now we have 7/10. Is that what this decimal is? Did anybody get to 7/10 a different way? There's another way to get there. Addie B, what'd you do?
14 over 20 divided by 2.
Remember how on all of the other ones I said try and divide it by 2 because it might make your life easier. Divided by 2, but we couldn't because all of the others were odd numbers on top. What's 14 divided by 2? 7. 20 divided by 2? 10. And then we would have went straight there. Okay, all of those ways are okay. It's whichever way works best with you. But when you give your fraction as a decimal, you always want to give it in the simplest way possible. So you don't want any extra zeros at the back if you do not need them. Does that one make sense? Why we could divide by 2, and on any of these you could build them up bigger. It's just you would have more zeros to cancel in the end. Okay, go ahead and turn the page. Courtney hit the bullseye 3/5 of the time when playing darts. Write 3/5 as a decimal. Lainey, is this a option 1 type problem?
No.
Why not?
It's because the denominator's not a 10.
Yeah, the denominator is not a 10, a 100, or 1,000. Can I get the denominator to a 10, 100, or 1,000? Okay, so that means it's an option 2, kind of one of the medium ones. So I'm going to write down 3/5. What do I have to do to it, Lainey?
Times 2.
Multiply them both by 2. So that would be 6/10. And how do I write that as a decimal?
0.6.
Good job, 0.6. And this is another one. I'm just going to show you another example. If we took that one to 100, 5 times what equals 100, Carter? 20. 5 times 20. So what's 30 times 20? 60. So I'm going to show you here. That would be 0.60. Is that the best answer? No, because we know as a decimal we don't need that end 0, but also I could have canceled those zeros right there to get that 0.6 also. So for a lot of these, you could add those extra zeros when you're working it. It's just at the end you got to get rid of them again. That's why we always try and get to the smallest denominator. Okay, number 8. Yesterday it rained 9/20 inch. Write 9/20 as a decimal. Aubrey E., is this an option 1 problem? Why not? Okay, doesn't end in 10, 100, or 1,000. Can I easily get 20 to 10? 20 to 10. Yeah, by dividing by 2, but why can't I divide by 2 in this problem? Yeah, because the 9 can't divide by 2 and get a whole number. So what do we have to build this up to, Aubrey? 100. So 20 times what equals 100? Times 5. And what is 9 times 5? 45/100. And what is that as a decimal? 0.45. Okay, then we got to the brain builders. Remember, it's been about 5 years of brain builders for you. What's usually true about the brain builders? They make you think a little bit more than the other ones. Usually you have to read carefully, zoomed way in, and sometimes they surprise us where it's like, yeah, that one's not hard at all. You just have to read carefully. So number 9 says, Camille shaded 18/30 of a model. Write the decimal that represents the unshaded portion. So something I want us to get used to hearing is if you got 18/30 as a grade, what does that mean? If I wrote that fraction at the top of your math paper, Gabe, what does that mean? Yeah, you got 18 out of 30. Anytime we're looking at a fraction, we could say the words out of in place of the fraction bar. So what this one means is 18 out of 30 are shaded. It asks me to write the decimal that represents the unshaded portion. So first, how can I figure out how many are unshaded? Elise?
Subtract 30 minus 18.
Yeah, if 18 out of 30 are shaded, then the first thing we would have to do is 30 minus 18 to figure out that 12 of them are unshaded. But 12 out of how many are unshaded? 30. 12 out of 30 are unshaded. So this is the fraction we are working with. Now, a lot of people struggled with this one because they couldn't get 30 to 100. Can we get 30 to 10? By doing what, Addie? Dividing by 3. So let's look at the top number. Can the top number also be divided by 3? Raise your hand if you made this one way too hard. Okay, so 12 again, always shoot for the smallest one first. Divide by 3, divide by 3. So that would be 10. What is 12 divided by 3? 4. How do we write that as a decimal, Hutley? Yeah, so 0.4 are unshaded. If you got a different answer, that means it's incorrect. But I'm going to work it a different way now. Okay? So, if you didn't notice that, if you were like, okay, it's not a 10, a 100, or 1,000, I can't get 32, 10, 100, or 1,000, even though you can. Sometimes you miss it. That's okay. What is option 3? Kinley? Divide it out. So I'm going to show this one divided out just to show you it works every time. So 12 divided by 30. I'm going to write it a couple different ways. That's saying 12 divided by 30. That's the same thing as this fraction. These two problems are saying the exact same thing. When I set it up to work long division, 12 divided by 30. These are all the exact same thing written different ways. Now, when you go to solve this, how many times does 30 go into 12? 0. I'm going to put it above the 2. How can I write 12 with more digits so that it still has a value of 12? Elia? Okay, if I put a 0 after the 2, it now says 120. So what else do I have to add? A decimal point. So I have to add my decimal point in my problem. If I have a decimal point in my problem, I also have to bump it up into my answer, straight up into my answer. Now, I can work it a little bit further. How many times does 30 go into 120? 4. 4. 4 times 3 is 12, and then I add my 0. I have nothing left over. So what was my answer? 0.4. Did I get there 2 different ways? Do I care which way you use? No, I want you to have different tools in your toolbox so that if one way is confusing or you get stuck, you have another option, okay? And again, this option works every single time. It's not always the easiest, but it does always work. Okay, number 10. I'm going to call this guy Paul. I don't know how to say his name. Paul missed 3 out of 15 questions on a quiz, or 3/15. Write the fraction of questions Paul answered correctly as a decimal. So if he got 3 out of 5 wrong, Fisher, how many did he get right? What? If he got 3 out of 15 wrong, how many did he get right, Fisher? He got 12 out of, how do we write that as a fraction? 12/15. So he got 12 out of 15 correct, but it wants that as a decimal. Now, this one we can get to 10 in 2 steps. So let's use what we do know about fractions. What do we know about that fraction? Just anything you know about that fraction. Gabe. If you gave me that fraction as a final answer, what's wrong with that as a final answer? Can anybody tell me that? And again, we're just getting into starting fractions, so this is kind of thinking back to last year or some of our weekly worksheet skills. Elia? Okay, it wants it as a decimal. Okay, you're right. It's asking me for a decimal, not a fraction. But if it wanted a fraction answer, why is that not a perfect fraction answer? Fisher?
Because it's not 10, 100,
Well, that's to get it to a decimal. Carter?
It's not in simplest
It's not in simplest form. When you guys look at this fraction, that's something I want you to start thinking about. Is that the best answer? Okay? The best answer is always in simplest form unless it's asking for equivalent ratio or equivalent fractions or something like that. Aiden, What can I do to 12/15 to make it in simplest form? How do I simplify fractions?
You divide them by
Common factors, right? What's a factor that goes into both 12 and 15?
3.
3. So Bryson, if I take 12 divided by 3, what do I get?
4.
4. And what's 15 divided by 3?
5.
5. So I get 4/5 if I reduce it down. Now, is 4/5, can I change that to a decimal real quick? No, but Gabe, what can I do now that I see it?
Oh, you can times it times 2.
Yeah, can I build 5 up to 10, 100, or 1,000? Yeah, so these are the ones that in 6th grade, they're working with equivalent ratios, which is fancy name for essentially the same stuff that you guys are doing at a higher level. I call these ones that you have to break down before you build up. Sometimes we can just build them up to where we need them to be. Sometimes we have to break them down and then build them back up. So this is one where you'd break it down and then build it back up by multiplying by 2. And we would get 8/10 or 0.8. But again, this is one where that's a little bit confusing. That's the only one we've had like that so far under the brain builders. What option always works? Carter? Dividing it out. And again, it's not always the easiest, but it does always work. So I'm going to show you this one. 12/15 is saying 12 divided by 15. So I'm going to set that up. 12 divided by 15. How many times does 15 go into 12? 0 times, so I put a 0 at the top. What else do I have to add, Addie?
A decimal point and then another 0.
A decimal point and at least 1 0, and then I move my decimal straight up into my answer. 15 into 120. This is where we may need to go out to the side and make a list of multiples. Okay, I'll do it quickly. Times 1 is 15. Times 2 is 30. Times 3 is 45. Times 4 is 60. I'm going to stop there. Why can I stop there? Using number sense. Using my number sense up here in my brain. Hutley?
Because it's 60 plus 60 equals 120, and then you just add 4 more to the
Yeah, if times 4 is 60, then I know times 8 has to be 120. And I know that's what I'm trying to shoot for. So I'm going to go ahead and do my times 8 right here. 8 times 15 is 120. So do I have to drop any more zeros? No. Did I get the same answer? Yeah. Did I just make that look a lot easier than what you guys did last night? Okay, just remember, option 3 is always an option. Okay, option 2 on this one is a little bit trickier because it's 2 steps. Okay, I agree with that. But option 3 always works. It's not our favorite. Why is it not our favorite? Because it's the longest way, okay? But it should be kind of in our back pocket as a way that always will work. Addie?
I did 12 over 15 times 2 equals 24 over 30 divided by 3.
Okay, so Addie did the same idea. She just did it backwards a little bit, which is fine. So she said she doubled it first. So she did times 2 times 2. And that gave her 24 over 30. And she said, hey, I'm still not at 10, but I can get to 10 by dividing by 3, and she still got 8/10. So does her way work? Yeah, and look at the math. She did times 2 divided by 3. We did divided by 3 times 2. So essentially, did we do the same thing? Yeah, we just did it in a different order. Elise?
I did the first one, but instead of times 2, I did times 20 and then canceled 2 zeros.
Okay, so what did you get when you took 15 times 20?
I divided 12 by 15 divided by 3, and then I got 4/5, and then I
Okay, so you did times 20 here and got 80 over 100. Yep, that works too. Okay, so that's what's confusing about these is you have options. Okay, and really you go with whatever option is easiest for you. And on one problem, you might like option 2. And if it's a multi-step option 2, then you might say it's easier for me to just divide it out. Okay, let's keep going. Number 11. Bashan needs to sell at least 0.3 of his collection of sports cards to make room for new cards. Is 3/20 of his collection enough? This is a comparison problem. We are trying to decide he needs to get rid of this much. Oops, he needs to get rid of this much. And he's actually getting rid of this much. And it wants to know, is that enough? What do I have to do before I can compare those two numbers? Addie? Yeah, or I can change 0.3 to a fraction. I just have to make them comparable. Anytime you're comparing numbers, you have to make them comparable. So if it's a mixture of decimals and fractions, you either have to make them all decimals or all fractions. It doesn't matter. I'm going to do it both just to show you it doesn't matter. So I'm going to kind of label my work, though. He needs to get rid of 0.3. He actually gets rid of 3/20. And it wants to know, is that enough? Does he have enough space for all of his new cards? So if we change this to a fraction, what is 0.3 as a fraction? Hutley? 3/10. Why can't I compare that to 3/20 yet? We kind of can with number sense, but let's do it with, I can look at it and tell. Carter? They don't have the same denominator. What can I do to make them have the same denominator? I could change either one of them. Which one's going to be the easiest to change? A 10 into a 20 or a 20 into a 10? Okay, because that I would have to divide that 3 by 2 if I go the other way. So I'm going to do times 2 times 2. So he needs to get rid of 6/20. If I could do math, 6/20 of his collection, and he gets rid of 3/20 of his collection. Did he get rid of enough? No, because 6/20 is greater than what he actually got rid of. Okay, so we've came up with our answer. He does not get rid of enough. He needs to get rid of more of his cards. If I did the decimal way, I'm going to come back to this 0.3. Okay, how do I change 3/20 to a decimal? Fisher? What? Times 5? Okay, so I'm going to do times 5 times 5. So that is 15/100. How do I write that as a decimal, Fisher? 0.15. Now, if I'm comparing this decimal to that decimal, what do I have to do before I can compare them, Braylon? I don't have to multiply. I have to make them comparable. What do I have to do to decimals to make them comparable? Not denominator, because decimals don't have denominators. You're on the right track. Fisher? Yeah, I have to make them the same number of decimal places. Do we still agree that 30/100 is greater than 15/100? So that he still did not get rid of enough. So is 3/20 of his collection enough? No. And our reasoning would be because I always give it in my original form. 0.3 is greater than 3/20. To do the math and figure it out, I need them the same form, but I always give my answer exactly how they gave me the problem. That one was kind of tricky. Amelia bought 9/12 pounds of sliced salami at the deli counter. Which of the following decimals did the scale show? So it's asking which decimal is equivalent to 9/12. Is this an option 1 problem? Nope. What about option 2? It can be. Lexi, when you see 9/12, is that in simplest form? Or is there a number that you could divide them both by? Yeah, we can divide them both by 3. If you don't like doing the long division, my suggestion is always try and break it down. If you can't easily get there, see if you can break it down. And sometimes when you break it down, you're like, nope, still can't. What is 9 divided by 3? 3. And 12 divided by 3? 4. Does that make it an option 2 problem now? Clara, what can I multiply 4 by to get it to be 10, 100, or 1,000? By 25. So I'm going to do times 25 times 25. So we get 75 over 100, which is that one. And here's something I haven't mentioned so far. If I took 9 divided by 12 and did the long division, I would get 0.75. If I took 3 divided by 4, guess what I would get? 0.75, because if the fractions are equivalent, you guys know how to do equivalent fractions, that means when I divide it out, you would get the same decimal answer. Which one would be easier to divide out? 9 divided by 12 or 3 divided by 4? Do you guys know your multiples of 12 or your multiples of 4 better? Probably your multiples of 4. So that's why I suggest anytime you have a fraction that can be reduced, reduce it first. Because even if you end up having to divide it out, you're dividing out smaller numbers now. Okay? Clear as mud? I know. Is it clearer than mud? Okay. On your piece of loose leaf in front of you, go ahead and close your book. We're going to do a few more examples, just because I feel like our confidence on this isn't quite there yet, especially those last ones. I want you to go ahead and title your loose leaf. I don't have buttons. I don't know what happened to my buttons. I'll use these ones. Go ahead and title your loose leaf, Chapter 8, Lesson 8. We're not going to do a ton of examples. We're going to do one all 3 ways, and then I have one more thing to show you. Wyatt, give me an option 1 fraction. 7/10. Okay? Let's write down 7 over 10. Why is that an option 1 fraction, Wyatt? Yeah, we already have a 10 as a denominator. So what is my decimal form, Bryson? 0.7. Okay, that's our option 1. Let's work that same fraction as if we don't notice. Let's pretend we don't notice that the denominator is a 10. And we're like, hey, it's an option 2. I can easily get 10 to 100. What would I do, Carter, if I'm trying to do this like my option 2 method? Yeah, I could say, I can easily get 10 to 100 by doing times 10 times 10. So we would get 70 over 100. From here, we can see that, I could cancel some zeros, and then your brain should say, I could have just kept it a 10 there. Okay, let's pretend we don't see that yet. That would be 70 hundredths, which we know the best way to write that is as what, Augie? So I have 0.70, but what's up there that I don't need?
0 in the hundreds place?
Yeah, the 0 in the hundreds place. So I could write that as 0.7. And again, I could have caught it there. If you ever have a 0 on top and bottom, you can always cancel them. Okay, let's say you're just really not awake when you're doing this, and you're like, option 1 doesn't work, option 2 doesn't work. What is option 3? Again, I'm just proving to you that it works every time. It's just not always the easiest. What is option 3? Addie? Dividing it out. So we're going to write this a different way. That says 7 divided by 3. It's just or 7 divided by 10. When we see it, we usually just say 7/10. but it is really saying 7 divided by 10. When we set it up to do long division, it still says 7 divided by 10. A lot of students say it backwards. I've been trying to correct you all year when I hear you say it wrong, because now it's important. Where does the 7 go? Hutley? Inside. So 10 goes on the outside. Now I'm going to come over here and do some scratch work. Lainey, can you help me with this? How many times does 10 go into 7? 0 times. What do I have to do to keep going? Good job. A decimal point and a 0. And I'm not changing the value. It still says 7 divided by 10. Lainey, if I add a decimal point in the problem, where else do I need a decimal point? Yep, up at the top. And then how many times does 10 go into 70? 7 times. 10 times 7 is 70. And I am done. Did I still get the same answer? Did I still get the same answer? Yeah. So I'm just showing you it doesn't matter which method you choose. Okay, if you want to divide out every single problem, you can divide out every single problem, but is that always the quickest method? Okay, one more thing I'm going to add on today. Only new thing. All my buttons are gone. What if it says 4 2/5? It really doesn't change our work. Aiden, what's the only thing that it changes?
Instead of a 0 front, it's a 4 in front.
Yeah, in a mixed number, our whole number is out in front. In a decimal, our whole number is to the left of the decimal point. So when I'm doing these ones, here's what I do first. I write down 4 point, just so I don't forget it. Because that's a common error. Is people will say 4 2/5 is equal to 0 point something. Then we just have to focus on the 2/5. With the 2/5, and for some reason all my buttons are gone, so I can't scroll down, so I'm going to squeeze down here. Focusing on my 2/5. Elise, is this an option 1, option 2, or option 3? Option 2. What can I easily get that 5 to? Smaller. Go lower. 10 by doing what? Yeah, so we would get 4/10. Emily, what is 4/10 as a decimal? 0.4. Now, is my answer 40.4 or 4.0.4? No, can we have 2 decimal points? So, Hutley, what is my answer?
4.4.
Yeah, my whole number stays the same, and really I'm just doing this to get the decimal portion of it. So 4.4. I did throw 2 of those on your worksheet for today, because is that really new? No, it's stuff you already knew, you just haven't seen it. So tonight, you have a worksheet that's very similar to last night's homework. I'm hoping that your understanding is a little bit better than it was yesterday. Do you guys all feel like you understand it a little bit better now? Okay, perfect. Let me stop this and I'll pass that out.